Hi everyone, today we're going to talk a little bit about significance testing and SPSS and choosing the right statistical test for the appropriate research question. So just to recap, I made a slide up here. I'm going to demonstrate, and again, as always, we'll do a little bit of bouncing back and forth. There we go. Right. Okay, so we see here a couple of steps for hypothesis testing, and I'm going to go over these right now. The first thing that we have is to develop the null and alternate hypothesis from the research questions. So we are typically given, or we create some sort of general research question about the data that we have. We're either looking for some sort of relationship, or we're looking for some sort of association between variables, or we could be looking at differences between variables. So there are typically these two types of questions. There are the questions of relationships that we could be testing, and there are the questions of differences between groups or between means of variables. So we have these research questions, and we're trying to then develop a null hypothesis, which we've talked at length about, that null hypotheses are typically boring. They are saying that there's no relationship. They're saying that there is no difference between groups, between variables. Or we have alternative hypotheses, which are much more interesting, that say that there is a relationship between variables, or there is a difference between variables, between groups, between means, so forth. So having a research question that is specific and appropriate is important, because that allows us to then create our null and alternative hypotheses. And when we create a null or alternative hypothesis, we need to be very specific. So when we're talking about them in English, in plain English, we need to discuss whether or not they are testing, one, what groups they're testing or what variables they're testing, and two, are you testing a relationship or are you testing a difference between groups? Those are the things that are very important to understand. Relationships versus differences. From there, we need to determine the appropriate test statistic. And to determine the appropriate test statistic requires us to know about the measurement level. So are we testing categorical variables, or are we testing continuous variables? So we need to know what the measurement level of our variables are. And again, we need to know what they are, and we need to know whether we're testing for a relationship or whether we're testing for significant differences. Okay, so I've created here, well, I haven't created, but there was a slide that I had mentioned in one of my previous slides on how to determine what the appropriate test statistic is. And I just mentioned there's the idea of understanding whether you're testing for relationships or differences, and then what's the measurement level? Is it categorical or continuous? Remember, categories are categorical, and continuous are numbers that go from 1 to whatever. They can be interval, or they can be ratio scales, right? Okay, so I have on this analysis, on this slide, the first part was summarizing univariate data. And if you recall, univariate means one variable at a time. So these are statistics like descriptive statistics, your mean, your standard deviation, your variance, your mode, your median, etc. Right? And we recall that these descriptives depend on whether the measurement level is, again, categorical or continuous. We also said that there was central tendency, univariate descriptive statistics, and dispersion statistics. All right, so what we're focusing on is differences between relationships or testing significant differences. Again, so you see, whoops, let me just move over. So you'll see here, I'm going to share the entire screen so I can use my pointer. Whoops. Share the screen. Come on. Okay, so what you can see here is that there's relationship statistics and difference statistics, significance of differences versus exploring relationships between variables. So what I mentioned was how to choose the appropriate test. And we have here, let's say we started off originally with exploring relationships between variables. Are we going to explore the frequency, or are we going to explore measurements? So there are two different types of relationships between variables. There's relationships between categorical variables, and there's relationships between continuous variables. So what we have here is relationships that are frequency based, that are categorically based. Now, what happens how do we decide which test statistic we're going to next? Well, the next question was, are we comparing the frequencies of a sample distribution to the theoretical distribution? If so, we're looking at the chi-square goodness of fit test. Are we looking for associations between variables, multiple variables in our sample? Again, this is testing a relationship or an association. If we're looking for relationships between categorical variables, then yes, we are using a chi-square test for association. So the chi-square test of dependence is what we're using here. Again, we're exploring relationships between frequency, or aka categorical variables, and we're exploring either one as a chi-square goodness of fit, or two as a chi-square test of association. Moving over here, if we're looking at measurement variables such as continuous variables, our next question is, are we looking for a degree of relationship? So this is the amount of a relationship. This chi-square tests, are they related between categorical variables? This tests are, how related are they? And to do that with interval variables, we use what's called the Pearson's correlation coefficient, or also known as R. If we are testing the level of a relationship, the level, degree, strength of relationship between categorical variables, we can use what's called Spearman's rho, the Greek letter rho. So again, correlation demonstrates the degree, the strength of a relationship. So to recap, we have chi-square tells us the goodness of fit between a sample and the theoretical distribution of categorical variables. The chi-square test of association or dependence is used for when we're looking for relationships between, whether or not relationships exist between two categorical or multiple categorical variables. The strength of the relationship is tested by either Pearson's correlation for continuous variables or Spearman's rho for categorical variables. And then if we're looking at the effect of predictors on a dependent variable, we then use regression. When we have one predictor, we are just using univariate regression. But if we have more than one predictor, then we're using multiple regression. Okay, so these are all of the tests that explore relationships between variables. Are they variables related or not? And not only are they related, but are they significantly related? How strong are they related? And in the case of regression, what's the effect of that relationship? Okay, so that talks about this branch of the tree on relationships between variables. Again, does our research question ask us to explore the relationship between the variables? That will determine whether or not we use this part of the tree. And from there, we can use the flowchart downwards. If the research question is asking us to look at the significance of differences to test whether there are differences and how different they are they significantly different, we then move to this branch of the tree. I just want to go back for a second to make sure I'm doing right. Okay. All right. So now the question, if we're testing differences, we have these variables, is how many groups do we have? How many groups are we testing differences between? Whether or not they're significant. So we're going to look at this flow chart again. We're going to say, okay, are we testing one group? We're comparing a mean to a specific value. Typically, we're comparing the mean to the sample mean to the population mean. Okay, so when we use that, we use a one sample t-test. This is comparing the mean difference. We're doing mean difference comparisons, and whether or not these mean differences are significantly different than another mean. One mean is different than the other mean. We're looking at a one sample t-test to determine whether X bar, which is the sample mean, is different from mu, which is the population mean. So in order to find that out, we would use a one sample t-test. Again, this is one mean compared to the population mean. What happens if we have two means? We want to compare two different means, two different variables means. And again, we can only get means when we have continuous variables, by and large. Or at least that's what we're going to be focused on here. So if we have two means, our next question is, are these means independent or are they related? Well, what determines independent means versus related means? Well, an independent mean is when there are two or more variables or more groups, in particular, of responses that act like they're independent from different populations. So again, remember what we've talked about with populations. The question is do they act like they're independent of each other, that they're sampled differently, so to speak? So the book talks about an independent sample as being the results of interviews with males and female coffee drinkers to compare male, which would be one population, versus female, which is another population of coffee drinkers. Okay? If we have independent samples, then we would, of two means, we would then use Go look here, interval, we use an independent samples t-test. So now that's two independent means, independent samples, okay? The next type of t-test is a related samples t-test. And again, we want to know if the samples are related. So the book describes related samples as two or more groups of responses that originated from the same population. So we just previously talked about male versus female coffee drinkers, correct? Well, now the question is, how about male coffee drinkers versus soft drink drinkers, right? We now are sampling from the same population, males, but we're looking at male coffee versus male soft drink. It's the same sample that we're sampling from. So if the sample is related, we would then use, again, two means, related samples, interval data, scale, continuous variables, a paired sample t-test. Okay? So to recap, we have three t-tests that we've talked about. A one sample t-test, which compares the mean to a specified value, which typically the population, so the sample mean to the population mean. We have two samples that are independent. So we would then use an independent samples t-test. And then we have two samples that are related. So we would then use a paired sample t-test. Okay? So we have 1, 2 means. Now what happens if we have multiple means? Well, if we have multiple means, again, 2 is multiple, so technically we could use a t-test if appropriate. The alternate is typically used when there are three or more samples. We would then use, again, assuming that they are independent samples, we would use a one independent variable, one-way ANOVA. We've talked about ANOVA as analysis of variance. So now instead of using the means, we are using variance to determine whether there are differences between groups. And remember, variance uses the mean to determine the dispersion of the data. So we're still using the mean here, but we're doing it using the variance around the mean of multiple groups, multiple means. Okay, so again, we're means comparison. So one mean is a one sample t-test. Two means that are independent is an independent samples t-test. Two means that are related is a paired sample t-test. And more than two means is a one-way ANOVA. We're just going to deal with one-way ANOVA for now. So to recap this slide, first we have univariate data summarizing it with descriptive statistics. Second, we have looking at the relationship significance, whether or not relationships do exist between variables. And we looked at a comparison of the sample to the population using the goodness of fit chi-square, or relationship of categorical variables as a chi-square test of association or a chi-square test of dependence. We also looked at relationships between variables of interval or scale or continuous variables as being Pearson's correlation as the strength of a relationship, and then the effect of a relationship was regression. Again, that was the exploring the relationships part of the tree. The difference between means part of the tree was looking at one sample t-test for one mean, comparing the mean of a sample to the mean of population. Two was comparing independent samples in an independent samples t-test versus a related samples t-test, a paired sample, or 3, looking at multiple means, multiple independent samples. So 2 or more means, we then use a one-way ANOVA. Okay, so let's go back to the slide. So we've now come down to number 2, determining the appropriate test statistic using that slide. The third part is to calculate the test statistic. Now we have the formulas to be able to do that, but we can also do that with SPSS, which calculates test statistics really quickly, particularly when we have a lot of data, and that's very helpful to us. We'll go through a little bit of that in a second. Fourth, we find alpha at 0.05 on the table, on the distribution table, and we use that to determine the critical value. 5, we compare the test statistic to the critical value. And we've done some of that where we've looked at the distribution and we determine where the critical value is, where the test statistic is. Based on that, do we accept or reject the null hypothesis? If we use SPSS, we can compare the test statistic significance level easily. They give us the test statistic and they give us the test statistics significance level. So this makes it very easy for us to determine whether or not we accept or reject the null hypothesis. And therefore, do we accept or reject the alternative hypothesis? And that is number 6. Decide to reject or support the null hypothesis, and thus to reject or support the alternative. The next question then is, how do we figure this out? Well, if we're looking at SPSS output, SPSS will give us significance levels, as I mentioned here. And our question then becomes, what do we do with the significance levels? If the significance level is less than 0.05, that means the test statistic is significant. So what does that mean? That means we reject the null and we support the alternative. Okay? So what happens? What does that mean? Well, again, it depends on what our hypotheses are asking. If the test statistic is significant, if it's less than 0.05, the test statistic is significant, that means that there is either a significant association or relation. What test do we use that with? Chi-square, or Pearson's correlation, or it means that there's a significant difference between means. That means that if P is less than 0.05, if we have a t-test, the t-test is significant, so there's a significant difference between means. Or if we use ANOVA, it means there is a significant difference between at least 2 of the means. The converse is that if the P level is greater than 0.05, then the test is non-significant and we support the null hypothesis. There's either no relationship or there's no difference between means. The last part of this is to interpret the implications of step 6. So we can decide whether we accept or support or accept or reject the null hypothesis or the alternative hypothesis. But that doesn't tell us managerially, what do we do with that? If I say there's a significant difference, how do I interpret what that difference means? Well, again, that requires you to go back to the research question and use whether or not you accept or reject the null hypothesis or the alternative hypothesis to answer the research question, now that we have some evidence from hypothesis testing. Okay? All right, So we've done quite a bit already between developing a hypothesis, which we have in a previous YouTube video. We have determining the appropriate test statistic based on this particular chart. We have calculating the test statistic using SPSS, which makes the formulas that we're given very simple. We talk about comparing critical values and test statistics to each other to determine whether or not we support or reject it. And SPSS makes that really easy because it gives us the significance level. And then we interpret our hypothesis, the outcome of our hypothesis testing, and translate that into managerial terms. What is this telling us about differences between groups? What is this telling us between relationships between groups? If there are multiple relationships between groups, can we figure out strategically how to answer a certain question, so forth. Okay, so we've done quite a bit with hypothesis testing, hypothesis development, hypothesis testing, hypothesis reading and interpretation of data. Now let's do a little bit of this in SPSS. So I'm going to open up the national insurance data in SPSS. This is one we haven't really worked a lot with, but I'd like to work with now. And I'm going to share that screen. Okay, so what do we have here? We have this data here, okay? And I had mentioned a couple of times about which tests we use. Do we use relationship tests or means tests? From there, do we look at relationships as being associations for categorical variables? Do we look at strength of relationships as being continuous variables? Or do we look at effects of relationships based on continuous variables or categorical variables? Then I also talked about, again, whether or not we look at testing differences between a sample mean and a population mean, between independent means, between paired means, or between 3 or more means using ANOVA. These will all determine which statistics we use in SPSS. Okay, so what we have here is the general, we have here analyze, compare means, and we can run multiple tests that we've discussed just now from this, okay? So let's say I want to compare a one sample t-test. I want to compare a population mean to a sample mean to a population mean, okay? Now let's say from this, I say I want to compare whether or not people in this survey believe that employees of National are always willing to help them. Now I've sampled several people. Let me see how many people I have sampled. I've sampled about 285 people. And I want to know of that sample if the mean of this sample is significantly different from the mean of the population. So what will I do? I will go to Analyze, Compare Means, One Sample t-test. Now I just want to make a mental note that that variable name was P17, okay? Going to show the names of the variables. And if I go to options, it gives me my confidence interval, but I'm not going to do anything with that right now. If I have in my hypothesis a value that I want to test it against, I can enter that here. I actually don't know what the population mean should be. So I'm going to leave that alone for now. But if I know, or if I have a hypothesis about the population mean, I enter that here. And then I click OK. Now SPSS gives me an output. It gives me the number of sample, the mean, the standard deviation, and the standard error of the mean. It gives me a t-test statistic, and it gives me the degrees of freedom for that test statistic. It then gives me the significance. It gives me the mean difference, which I used was 0 because I don't know what the mean actually is of the population. And then it gives me what's called the 95% confidence interval of the difference. And that confidence interval, we have not really discussed anything about confidence interval testing, so we'll leave it there. So we'll just focus on this. So the t-value, the degrees of freedom, and the significance. Now, I mentioned on my slide that if the significance is less than 0.05 in SPSS, this test statistic is significant. So we reject the null hypothesis and support the alternative. Remember, the null hypothesis is generally boring. It tests no difference between means. It tests no association between variables. Remember, I used a t-test, so I'm looking for a mean difference. I used a one sample t-test. That one sample t-test would suggest that I'm looking to find whether or not there is a significant difference between the sample and the population. In this instance, this is less than 0.05, so there is a significant difference between the sample and the population at p less than 0.05, right? Significant difference means the test statistic is significant. We reject the null hypothesis, support alternative. My hypothesis would have been customers believe that there is no difference between the sample mean of employees willing to help versus the population mean. What does this find? This finds there is a significant difference between the population and the sample means. Okay, so that was the t-test. Let's do another one. Whoops. I am going to look at analyze, compare means, independent samples test. Now the question is, I'm looking, you'll see here a test variable, which would be your dependent variable, and a grouping variable, which would define the groups, the relationships, okay? I mentioned before the independent samples t-test as being male coffee drinkers versus female coffee drinkers. We need to define what the groups are. So we would define male, we would define female. Well, that's the same thing here. We need to define which two groups there are. The test variable, I'm going to find out whether or not there is a difference between men and women on how safe they feel with their transactions with natural. Do they feel with national? Do they feel safe or not? Do men or women feel safe? And so again, the hypothesis would be men and women equally feel safe in transacting with national. Or the alternative would be men and women feel differently about their safety of their transactions with national. So the first thing I'm going to do is I'm going to move my dependent variable over here. And the next thing I'm going to do is find my grouping variable. My groups were gender. So I move sex over here, and I want to define my groups. Group 1 is 1. And again, this requires us to go back to the code book. Oops. I'm gonna do that. Yeah. So this requires us to go back to the code book. And the code book says male is 1 and 2 is female. So I'm going to go back here and go to analyze, compare means, independent samples. I'm going to define group 1 and group 2, okay? And if I go into this, I see my confidence interval, and I'm going to leave that for now. Now, when I hit OK, I have my independent variable, and then my grouping variable, which sample 1 and sample 2. And I'm going to click OK. Now you'll see here my next t-test, my independent samples t-test. It shows me the mean of male, mean standard deviation and standard error for males, and mean standard deviation and standard error for females. Now the question is, what do we do with that? Well, I had mentioned before that when we do an independent samples test, we need to look at whether variances are equal or not. Okay, so if we look at the test for dependence of the equality of variances, again, is it less than P of 0.05, then there's a significant difference between them. So we would use that would say there's non-equal, so therefore we would look at the equal variances not assumed. And we find, or sorry, the equal variances are assumed because we significantly equal, okay? So now we look at this, we see the test statistic is T is 8.843 with a 257 degrees of freedom, and the significance was 0.40. What does 0.40 mean? Well, it means that, again, if we go back to this, if it's greater than 0.05, the test statistic is non-significant. We would support the null hypothesis. What was our null hypothesis? Our null hypothesis was that men and women are equally safe in their transactions with national. Right? So if we're saying that there's significance level of, if we're saying that it's 0.40, we're saying that there is no significant difference between the groups. There is no significant difference between men and women. What does no difference mean? Equal, right? No difference means equal. So men and women feel equally safe with their transactions with national. Okay, so that's the independent samples t-test. Now let's find out about a paired sample t-test. So again, the paired samples means that there's a relationship between two groups. That the responses originated from the sample population. The same sample population. Okay, so we want to find out if there's a difference between, again, these people are answering from the same population. We have no grouping variable. We want to find out whether people think that national performs service right the first time and when they promise to do something, they do it. So is there a relationship between national, is there a difference between national promising to do it versus national doing it right the first time? So our hypothesis might be, our null hypothesis might be, national promises to do something and it does it is equal to it doing it right the first time, as opposed to national promising to do something and doing it right the second time. I want to switch these variables order. Okay. And again, I can change my confidence interval, but we're not going to do that right now. So I have variable 1, mean 1, and variable 2, mean 2. These are related means. And I hit OK. Now what's going to happen is it's going to show me the mean of it promising to do something. It does so is in standard deviation and standard error. Then the mean of the next one, performing the service right the first time. 5.2, standard deviation, standard error of the mean. When we do a t-test, this actually shows us what the correlation is. And if you recall, correlation is the strength of the association between two items, between two variables. This shows us, what does this show us? What happens if the significance is less than 0.05? Right? That means that it is significant correlation. And a correlation goes from 0 to 1, 0 to -1. If it's positively correlated and it's significantly correlated, then we would say there's a significant positive correlation. And we see that here, 0.734. So now the question is, okay, the two variables are highly correlated. Our question is there a difference between the means? Is there a difference between national promising to do something and national doing it right the first time? So again, we can look over here at our test statistic, the t-value at 270 degrees of freedom with a significance of 0.115. So what does that say? How do we interpret that? If the significance is less than 0.05, we would say it's significant, but it's not. It's greater than 0.05. So we say it's non-significant. There's no difference between national promising to do something and doing it right the first time. There's no difference. We accept the null hypothesis. There's no difference between the two. Okay? So that's what happens when we use a t-test, is we look at the difference between those two paired samples. Now, what happens if I add a third in? Because I mentioned that we typically use ANOVA. Just to show you, if I do a one-way ANOVA between the two variables, and promises to do so. Now let's add one more in, and that not only do they promise to do so, they do it right the first time. I want to see if there's a relation, if I want to see the factor between these groups, okay? What happens between the groups of, does it do it right the first time? And I look at that between groups and I say, when national promises to do something, it does so. Does that have any relationship between that and whether they do it right the first time? Yes. If they do it right the first time. So again, I needed to know what my grouping variable was. Do it right the first time. So there's a significant difference between national doing something and whether it does it right the first time, and also the same as whether it promises to do so, it does it right the first time. Do one more. What we can also use is what's called the univariate linear model. And I want my dependent variable if I'm looking at univariate means. Say when national promises to do something, it does it right the first time. Okay. And then I want to see if that is dependent on, sorry, let me, because I just saw a new variable. On a scale of 1 to 10, how would you rate the overall quality of service? That is going to depend on whether or not when national promises to do something, it does so. So dependent, independent variables, aka fixed factors, and we'll hit OK. And we'll see a univariate ANOVA. On a scale of 1 to 10, how would you rate the overall quality of service? Again, so between this depends on when national promises to do something, it does so. And we see significant differences. So this test is significant. People rate the quality of service differently depending on whether or not national promises, it keeps good on its promises. Okay, there's a lot to take in there on that, but that shows you in SPSS generally how we do this. And don't forget, if you're looking at creating descriptive statistics, you want to find out something about categorical variables, you may want to use the chi-square. So we frequently will do that when we're doing target markets. I want to find out the target market of national insurance. So I'm going to input all of my categorical variables. I want to find out based on if people had problems, what were their gender, marital status, age, family income, and highest level of schooling. Actually, I want to change this and say, would you recommend? Okay. The likelihood to recommend, is there an association with their gender, their marital status, their age, their family income, the highest level of schooling they've completed? I go to statistics, chi-square. Okay. I'll click OK. All right, so I now have crosstab tables, and I find chi-square tests for each of these. Is there an association between recommending national and gender? Chi-square shows non-significant, no significant relationship between recommendation and gender. Okay, let's move on. Would you recommend national to a friend? Is that related to marital status? Chi-square, non-significant. There's no relationship between insurance recommendation and marital status. How about age? Again, chi-square, 0.855. No relationship between recommendation and age. How about income? We look at this, 0.059. It's almost significant relationship, but it's over to the threshold. So there's no relationship between recommendation and income. How about schooling? Chi-square shows, yes, there is a relationship at less than 0.05 between schooling and recommendation. So we'll keep that. And that's the only relationship there is. So all we know is that people, there is a relationship between recommendation and schooling. Now, what do? Well, we look to see who's going to recommend in terms of frequency counts. Okay. Well, we know that people who went to high school or less will recommend, and even some college will recommend. What we really need to do is we really need to dig down into the expected versus the other frequency observed count. So I want to redo this crosstabs and hone in specifically on the significant one, which is the level of schooling. And I want to put in there the statistics and the cells observed and expected. Now let's redo that. We see that people who completed high school or less really were looking more at the recommendation than the people who are not recommending it. So therefore, we would say that our target market is probably, if we look here, there was almost 3 times more people recommending it, not recommending it in grad school. So it really requires us to, again, dig back into this and look at it and say, okay, what types of relationships can we establish based on these chi-square tests? Okay, so what have we done so far? Skip back. Okay, so we've looked at a couple of things, and the big things that we've looked at were these things. Let's share this screen back again. Come on. We've looked at developing the alternative, the null and alternatives from the research questions. We've looked at, from the research questions, developing the hypotheses, which test statistic are used. Are we looking at associations or are we looking at differences? And we look at differences, again, we can use equal, greater than or equal, less than or equal, versus unequal. We then determine the appropriate test statistic based on what type of tool we need and what the measurement tool is. Is it categorical or is it continuous? We then calculated the test statistic using SPSS. We then determined the critical value relative to that test statistic, or just looked at the test statistic significance in SPSS. And then based on that, we decide whether or not we reject the null hypothesis. Less than 0.05, we support the alternate hypothesis, or we support or reject the null we reject the alternate hypothesis if it's greater than 0.05, and support the null hypothesis. And then we translate that back to how we answer our research question. Okay, so that was a lot that we've covered so far, and I think what we're going to do is end it there, because we've done a lot about, namely, choosing the appropriate statistical tool and then figuring out from that statistical tool how to interpret the results, and then from interpreting the results, how that relates back to the appropriate research question. So we're going to end it there, and we will see you the next time.